Next lesson is 10S, surface area of pyramids and cones. Not sure why that's 10, unless we really want it to be spring and we're ready to go out and play some tennis. Not sure about that, but it might be. But now we're going to do pyramids and cones. Again, our state standard that we can solve real-world problems and mathematical problems involving surface area. So here we go. A regular cone or regular pyramid, either one, we're going to do cones in a little bit. The base is a regular polygon and the side faces are congruent isosceles triangles. This base will be the same all the way around, probably a square or an equilateral triangle. If I made this into a net, I would have my base and then 4 isosceles triangles that are off to the sides when I cut it apart. There it is. So my net consists of 4 triangles and a square base. Slant height. The height of any of the side triangular faces, sometimes called the lateral height. Now, this happens to be a regular triangular base, and then I have my 3 triangles that would fold up to the top, and so the lateral height is that height of that triangular face on the edge, on the sides. To find slant height, if we know the actual height of that pyramid and this distance, how would we find that slant height? Pythagorean theorem. A squared plus b squared equals c squared. 6 squared plus 12 squared equals c squared. 36 plus 144 equals c squared. 180 equals c squared. Now that doesn't come out nice. It's not a perfect square. So we have our choices. We can think of this to root both sides. Remember doing that? 9 times 20, 36 times 5. So I get 6 root 5. Equals C. Now, if we want to be fancy, that's our radical answer, or I can square root 180 and get an estimated answer of 13 4/10. And if I'm going to do arithmetic to find my actual surface area, I probably need the decimal to do that. Again, our standard, we want to be able to find surface area of polygons, or of prisms and pyramids. So here we go. Again, I'm going to need the slant height, which is perpendicular height of that triangle. A squared plus b squared equals c squared. 8 squared plus 3 squared equals c squared. 64 plus 9, 73. We root. So square root 73, 8.5 feet. If they don't give you the slant height, you have to find it. here. Total surface area, TSA. Now, we've just used SA, and that's fine, of a regular pyramid. That surface area is 1 capital B plus 1/2 PL. That L is my slant height. 1 capital B plus 1/2 PL. Capital B plus 1/2 PL. Where B again is the area of the base, P is perimeter of the base. So, slant height of 12, a regular square base. So surface area is 1 capital B plus 1/2 PL. Area of the base, 9 squared, 81. Perimeter of the base, 4 times 9, 36. Sorry about that. So, surface area equals 81 plus 1/2 times 36 times 12. 81 plus 1/2 of 36 times 12, 216. So my total surface area, 297 inches squared. 1 capital B plus 1/2 PL. You're just plugging and chugging. Find the numbers, chug and plug them in. All right, here's another regular pyramid. It doesn't look regular. This certainly doesn't look like it's 8, but if they tell you it's regular, that means that base is a square. Surface area is capital B plus 1/2 PL. So area of the base, 8 squared, 64. Perimeter of the base, 4 sides all the same, 4 times 8, 32. Surface area equals 64 plus 1/2 times 32 times 15. 64 plus 1/2 of 32 times 15, 240. Total surface area, 304 meters squared. Again, finding surface area of three-dimensional figures using formulas. Cones. Again, a cone, one base, but it's a little bit different because that cone shape that makes that cone, the formula is pi RL. Pi RL. 1 capital B plus pi RL. So, if I want to make a net of a cone, it kind of looks like this. Because this is just going to wrap around. So, here we have a lovely cone. It has a lateral height of 25 and a radius of 15 on the base. So, surface area is 1 capital B plus pi RL. So, my base, pi r squared. So, pi times 15 squared. 15 squared is 225. 225 pi. And I'm just going to put that right there. 225 pi plus pi times 15 times 25. So I get 225 pi plus 15 times 25, 375 pi. Add those together, 600 pi. And if I punch that in my calculator, 600 pi, I get 1,884.9559. So rounded 1,885 to the nearest whole centimeters squared. That's to the nearest whole square centimeter. Okay, here we have a lovely cone, radius of 11, slant height of 19. Surface area is capital B plus 1/2 pi RL. Area of the base, pi r squared. So we get pi times 11 squared, 121 pi. We're going to substitute that in. 121 pi plus 1/2 times, no, there's no 1/2. It's just pi RL. That's my mistake. I caught it though. Pi times 11 times 19. Aren't you glad I did that? 121 pi. We all make mistakes. It's if you catch them and fix them and not get upset about it. If I got upset every time I made a mistake, oof, my blood pressure would be through the roof. So 209 pi. What I learned from that is double check your formula. 1 capital B plus pi RL. So I get 9 and 1, 10, 3, 330 pi. I punch that in my calculator, 330 pi, and I get 1,036 7/10. So if I round to the nearest whole, 1,037 inches squared. And again, be careful because the directions will tell you in the problems what to round to. This is rounded to the nearest whole square inch. So again, our standard to be at a level 3 on our scale, I can solve real-world problems and mathematical problems involving surface area. So our I cans down here, I can use 2-dimensional nets to represent 3-dimensional solids, pyramids and cones. I can find surface area of rectangular and triangular prisms, but also pyramids and cones and cylinders. I can solve real-life problems.